Thanks, everyone. Eric is a partner of ours from OpenSearch Connections.
Nice to be here.
Aruna and I are at Amazon. So, what am I here to talk about today? I'm talking about the importance of data. So how do we get there? Well, search, we know, is strategic. And how do we know this? We know this by looking at our search box and seeing how many millions of dollars pass through that search box. I wish I knew the number. If I did, I wouldn't be allowed to tell you, but you know it's a very large number. So, even though it's so important, it never seems to work quite right. So here I am, I search for a jacket for warm weather, and I get a very, very warm jacket. But in fact, what I was looking for was a summer jacket, a jacket for warm weather. And that's actually true on Amazon.com today. So even Amazon.com, after millions of dollars of investment in search, is still not getting things right. So why is it so hard? Now, my claim is that one of the reasons it's hard, not the only reason, but one of the reasons it's hard is that there are so many different use cases that you can't have one solution that fits them all. So in the background, you're not supposed to read all the detail there, but even in a simple, what we might think of as a simple case of image search, there are many different kinds of image search. So if you go to, let's say, smugmug.com, which is a site for professional photographers, they have weddings on there. So if you search for grandmother on smugmug.com, you're probably looking for the grandmother at this particular wedding. If you go to Google Photos, on the other hand, you want to see your grandmother. And if you go to Shutterstock, you want to see anyone who looks like a grandmother, whether she's a grandmother or not. So one size doesn't fit all. Otherwise, I think we would have a universal search solution. We'd all go home, we'd just buy the universal search solution. It would solve all our problems. So how can you fix this problem? Well, a few years ago, I was at a conference at Berlin Buzzwords, and we had a bunch of search experts in the audience. And we did this, I'll do that again for the effect, Post-it note party, where people put up, what do you think is the most important thing that a search engine should do, or a search installation should do? And so they put up lots of things, and then we organized them in the usual way, in no particular order. Actually, those are probably in order of popularity. But then we asked them, so which are the things that you think you should be doing, but you aren't actually doing? So what's the gap between what you're doing today and what you think you should be doing? And we organized it by the size of the gap. And this is actually the results we got from this survey. So the first thing that people found was a gap, that they were not logging search actions. What do I mean by search actions? I mean, what do you do after the search? What is the evidence for the value of the search results you're getting? Now, there are many other things, all of which are important, by the way, like evaluating quality of results. Well, how are you going to evaluate the quality of results without seeing the search actions? So it's related. But I won't go into the other ones, because today's focus is going to be on this logging of search actions. I also talk a lot to AWS customers. And AWS customers, some of them are the largest users in the world, spending huge amounts of money, large search staffs. And I found that there are several gaps in what they're doing. The biggest gap, which sort of surprised me, was that many of them did not have a search specialist on staff. They had assigned search to talented search software engineers, talented data scientists, but they didn't realize that search is actually a discipline. There are actually things you should know about search. And one of the things you know about search, by the way, as if you've been around search for a while, you know some sort of standard counterexamples. It's a little bit like math. So if any of you have taken like proof-based math, one of the things you learn in proof-based math is the standard counterexamples. You say, how can a space be closed but not compact? Whatever. And in this case, there are all sorts of cute examples, like how many of you know the band The? Well, they're both stop words in the normal manner of things, and probably most semantic search engines won't get it either. So how do you handle the? Well, it's probably a special case. That kind of folk knowledge about what search is missing. So that is a huge problem. And if I'm talking to a customer, I tell them, you have to fix that first. I don't care what else you do. You have to have someone who is specialized in search. And if you don't have one today, either hire someone or train them. And by the way, the training that's coming up tomorrow is a good place to start if you don't have that experience. So the Think Like a Relevance Engineer by our friends at OpenSearch Source Connections. But then the next thing they found was a lack of logging. And I say, surely that's not true. Surely you're logging everything you're doing. And say, yeah, well, we have our HTTP logs, we have our web logs, whatever. But are you actually capturing the granular data you need to evaluate search? Not just, oh yes, 23% of searches result in purchases, but which searches result in which purchases. So I like to organize my thinking around improving search in this diagram, the virtuous circle of search improvement. And it has three basic parts: the search processing, that is, how do you get results, the measurement analysis of the results, and the search tuning. So let's start with generating results. This is the sexy part. Everyone loves talking about this. So if you look at what people publish about, they say, oh yes, we have a cool new way of doing this and such, or a more efficient way of doing thus and such. A lot of effort is done on this, and there are multiple techniques. I mean, we have query understanding techniques, we have query writing, we have lexical search, we have semantic search, semantic sparse search, multimodal search, re-ranking, all of these cool techniques. But how do you choose the best technique in your case? So that brings us to tuning, which isn't quite following the arrows, but that's okay. So that brings us to tuning. How do you tune your results? And one of the insights here is that there are different areas have different strengths. So semantic search, this is a search for some train station, subway station in Chicago, I think. And so if you do semantic search, it's really good at finding the stations, not necessarily this station. If you do lexical search, it's really good at finding things that are called the same thing as the station. But with hybrid search, you get a bit of both. So how do you tune and combine them? What method do you use for combining different searches? How do you do hybrids? I mean, a hybrid, you still have to make decisions about what comes up. And the answer is you have to collect and analyze data. And that's missing from a lot of our users. So what the User Behavior Insights project is all about is collecting fine-grained behavioral data. I want to know everything about what the user is doing with the result. It's about a standard schema. The schema is actually more important than the software. A standard schema for representing this data. So representing data about the searches, the search results, and the actions on the search results, all of the actions. So people ask, oh, should I track purchases or should I track clicks? And the answer is both. You can track whatever you can. Now, it turns out that purchases, for example, are a much stronger signal in an e-commerce case, but maybe you don't have enough of that data. So maybe you want to collect more of the earlier steps in search. A really critical thing you need to do is to trace your results causally, not chronologically. Weblogs are really good for giving you the chronology of what people did, but they don't tell you the causality. They don't say the result number 3 from this search on red shoes, the result number 3 was the one that eventually was bought. And then conversely, you want to be able to go back from the result that was bought and say, what did people search for to get to that result? Another interesting kind of analysis. So that's what I call causal connection as opposed to chronological connection. And finally, you want this data to be useful both for manual tuning and machine learning tuning. Why manual tuning? Well, it turns out manual tuning, you can do a pretty good job with manual tuning, especially if you have some guidance. Is it improving things? But of course, we also want to do machine learning as much as possible, much easier, well, easier maybe not, but much more effective, and we hope that it gives a better result. So that's what User Behavior Insights is all about, and my colleagues will tell you what we've done about it.
Thank you, Stavros. Moving on to the demo. We start with the demo, and we learn about the User Behavior Insights movement. Now, like Stavros was talking about, we have a standard schema that is defined that ensures that what you're collecting and what you're storing is available for you to build dashboards that give you insights into what the users are actually searching for. So there are 3 critical steps. So the goal of UBI with 3 critical steps. First, we instrument, make sure we track all the right metrics from the user interface, whatever that might be, whichever technology it is built on. Collect and store on OpenSearch. So there is a standard schema that is defined, but then that's flexible. You can add your own fields of your choice. You will see in a while how. And then build dashboards on top of the metrics that you collect. This demo that I'm going to talk about today is built on top of the Chorus application. It's a publicly available demo site that you can take a look at to see how the traces happen from the user interface. So here, I have highlighted a piece where you can look at some of the instrumentation that is done on the page. Search for a printer cartridge. There is a query which runs here. As you can see, there is an event which is posted that captures a bunch of fields from the user interface, from the UI, and sends it to the backend application. So this is the first phase, right? So you first instrument the right metric and make sure it goes to the right place. So in OpenSearch, we have two specific indices. One is the UBI queries, and the second is the UBI events. The UBI queries captures the queries and any changes to the queries that happens from the UI. And from Stavros's point, we want to make sure that these metrics are captured causally. So as you can see, the query ID helps you do that correlation from the time, okay, what did the user actually search for, which ended up in a conversion. And here, the other thing that you might also want to look at is the query. As you can see, the complete query that goes to the OpenSearch is actually stored in one of the fields for you to create any kind of dashboards of your choice. So this is the second phase, which is the collect. Similar to this, you define what are the metrics that you want to collect on the UI. So it can be the queries, it could be events. What are the events that you want to collect? So in this case, it's a product hover. So when I'm when I'm hovering over a specific product on the UI, there is an event which happens behind the scene, and this event goes into, again, you collect the metrics in the UBI events. And the same thing follows for every other metrics that you would like to collect. And in this case, it's add to cart. I'm making sure there is an event which happens. I click on the Add to Cart button, and the event is captured in the backend OpenSearch. So again, there is a post event, and the event name captures what exact event that happens. Here, in this case, it's an Add to Cart. And whatever message that you want to add, again, that is something that you can add. And this, again, captures the query ID, right? From the start of this session, what was the query ID that is passed on to the OpenSearch. And this event, again, is captured in your backend OpenSearch, which is, again, something you can leverage for your traces purposes. So add to cart. So these are some of the dashboards. There are a bunch of pre-built dashboards that come packaged with UBI. And then, of course, it's up to your needs, how you want to create your own dashboards. Some of the cool metrics, what are the top searches which has been done? What is the longest session duration? How long did the user stay on the page? Or the shortest duration? Other part is, the other is click position. On the results, right? What is the result? What is the which position on the results page did the user click on? And of course, the messages that you want to, again, something that custom messages if you want to send across to your indices, to your OpenSearch indices, that is one other thing that you can do. And this allows you to, this provides you a good insight into what kind of metrics that you have collected and how you want to present it. Now what?
Excellent. Thank you, Aruna. So, all right. So I get to talk about where we're going now that hopefully you're excited and you're going to deploy user behavior insights. So Stavros and I got to talk at OpenSearchCon in Berlin a couple of months ago about where the project was. At that point, we had just released our 1.0 version of the specification. So since then, a couple things have happened. One is we've actually gotten some community involvement. As Stavros highlighted, the specification, the shared format for sharing user and query data is really maybe the most important of this project, not the code itself. And so we actually have a specification GitHub repo linked there that is the generic specification. And we had people from multiple organizations. We had folks from eBay. We had folks from Snowplow. We had other folks in the OpenSearch community, David Tippett, contribute to, hey, this is where this specification needs to go and what it was missing in the 1.0 MVP specification. And so there are a couple of the changes that we made to our 1.1 version. So that got shipped a couple of weeks ago, end of August, and people are starting to look at it. So we want this to be a real specification, not just a OpenSearch community specification. And so some of you may be familiar with Snowplow. They're a vendor in the user analytics space. That's what User Behavior Insights is part of, user analytics. And they actually instrumented that same chorus demo that Aruna showed you, but instead of using our JavaScript client library for collecting events, they actually instrumented it with their very rich and robust platform. There's a little video. The data flows through the Snowplow platform and eventually ends up in an OpenSearch index that, because of the specification and schema, is in the exact same format as what Aruna showed you on our sort of reference implementation demo. So that's really exciting that some of the industry players in this space are looking at user behavior insights and saying, yes, we would like to tag onto that. That shows some value. We want to be part of it. And then lastly, I want to throw out a plug for Trey Granger's talk at 1 p.m. So AI-Powered Search is the book that's coming out. He's going to talk about a lot of how to use signals for machine learning-based boosting. And one of the things that he looked at UBI and said, hey, this is a great open standard for collecting signals data, right? What are users doing? And so he's going to be talking about how he used UBI data as an interchange format to bring that signals data in for a lot of the examples that he has in his book. So definitely make sure to check that out. A couple of other things. So, right, what's next? Well, one of the things is implicit judgments. Implicit judgments are a way of measuring your query and doc performance. How good are my search results? And now that we have all the raw data that we need in these UBI queries and UBI events indexes, we would like to actually be able to calculate implicit judgments right there inside our OpenSearch environment. And so this is our architecture diagram for how we're processing events. This is functionality that is coming out. I'll talk about the RFC in a moment, that you're going to be able to have in an upcoming release of OpenSearch. And it demonstrates one of the common approaches for doing implicit judgments calculations. So we have a processing pipeline here. We're starting with a sample data set of about 150 million events and 10 million queries. Maybe that's a lot of data, maybe not, but we're really trying to build a solution that works all inside OpenSearch. You don't have to delegate to an external pipeline because we want this to be sort of out of the box right here for everybody to use. So, and the very first implicit judgment algorithm we're going to use is called clicks over expected clicks. This is it's been around for a while. It's an industry standard. Amazon product used to use it uses it to evaluate their search product quality. Here is an example of the math that you can see. And the idea out of this is that we're getting an understanding of, for a query and a document in a specific position, which ones outperformed the average, right? We know everybody always clicks on the first result. What we're interested is products that were in the second or third or fourth position that outperformed the average of what products in those positions did. That's how we measure implicitly that this is useful. Why do we like implicit judgments? Because it captures a lot of the biases that we as human beings have when we're searching, right? We're really interested in understanding why do people want to click on certain things, and our activities, the data of all of us in aggregate, gives us a really strong indicator of our search quality. Okay, so implicit judgments coming soon to OpenSearch. Really excited about this one. We actually have an RFC. If you want to hit that QR code, it'll bring you right there to it. So we have an RFC out there right now for what we're calling the Search Quality Evaluation Framework. So we need a structure inside of OpenSearch for us to be measuring search quality over time, right? We've seen a lot of really interesting techniques for improving search quality. We need to make sure that we have a way of trying out these different techniques. And so we're rolling out a search quality evaluation framework that we're inside of OpenSearch is going to allow you to do this. Implicit judgments, clicks over expected clicks, is our first key one. So excited about that. So once we have our implicit judgments, that means we can actually do things with it. So right here is the data structure that we're trialing right now, again, as another index inside of OpenSearch to go along with our UBI queries and our UBI events. And we're building a data structure that is built around aggregating, filtering, and grouping individual search nerd metrics, right? What I like to call search nerds, NDCG, precision, recall, all of those, right? Classic information retrieval metrics. And so what this is going to let us look at is different metrics over time, their performance. We can track things over time, understand, is our search quality improving? Did we have a drop off when we did a release? We can understand, hey, we changed something and search got worse. What happened? We can look in there. A big one is this idea of search configurations, right? So right now, right, Stavros has said a couple of times, we need to understand what is the state of our algorithms and all the data inside of OpenSearch, right? So that we can do comparisons and be able to compare, this is what things look like on a Monday, and this is what they look like on a Friday. What we're at least introducing, if we're not covering the data side, is a search configuration is a label that you can give that can be stored to say, these are the algorithms that we're using, this is the pipeline that we use, these are all the tokenizers, and it gives you a label that lets you start comparing things together inside your open source cluster. So in this little mock-up here, right, we have 3 search configurations: baseline, research model 1, and research model 2. We're also adding the idea of a test query set, right? If we're going to be doing search quality metrics, we do need to, sort of compare the same queries over different search configurations. And so we're going to have a sampled queries and even some tooling we're working on to be able to sample your queries to have the right proportional set of queries for measuring search quality. As you can see, we have our individual queries, so you can drill down and look at your individual queries. There's some examples of metrics: NDCG, Jacquard, precision at 5, and what their values are. So this is useful data, right? We're going to be collecting this data inside of OpenSearch, but so what? Where do we go with it? Well, we're leveraging our OpenSearch dashboards. So here's an example of using a dashboard, and we're going to go ahead and look at Challenger 1. We had our baseline. We're going to look at Challenger 1. There's a couple of metrics. We're going to use DCG, discounted cumulative gain, and we can look over time and see how this is doing and maybe kind of sort and leverage some of the features. Did we have how is this doing? What's our highest value ever? What is our current value? It gives us a way of understanding the performance of our Challenger algorithm. We can go ahead and start looking at a couple of different metrics and laying them out. So this is all using OpenSearch dashboards. It'll all come with OpenSearch. Let's get a little more granular. So here's an example of, we're going to look at our baseline, and there we go. We're going to switch to Challenger again. And now we're able to actually look at the individual queries in our query set. This is a sampled set of queries. We're going to reuse them. They're an artifact that we use in our measurement. And then we can even look at these queries across multiple metrics individually. This can help us spot which are the queries that are underperforming. Why do they underperform? Oh, that's interesting. Here's some other queries that overperform. That's also useful information. Why do those queries do so well? And this lets us guide our tuning and optimization techniques going forward, thinking back to that virtuous circle that Stavros highlighted. So we're working on some more big ideas. Who likes violin plots? I like violin plots, right? So this is a great example of the types of deeper metrics that we want to bring inside OpenSearch dashboards. So on the left-hand side, those dots, that is a DCG metric on the left-hand side. A bigger number means a better quality of search results. And as you can see on the left, you can see each dot, each query. We have one really great search sitting there at the top and a bunch kind of clustered fairly down. That's our baseline. We can look at our Challenger and maybe compare it a little bit, and you can look at the weight of the violin plots to get a sense. So we're really excited to be taking advantage of some of the new Vega plotting libraries that are in OpenSearch dashboards to bring these types of metrics that previously really only were exposed to like data scientists and very custom dashboard tools to everybody who's using OpenSearch. So I think that gets me to where are we going, right, with this. So, we're in search. Search is a journey, and we like cycles, right? So one of the things is we have this user behavior information. And we want to get away from thinking of, I take some data, I build a model or an algorithm, I ship it, and I'm done. And so what we're looking at here is we're building on that user behavior information that we're currently gathering. We're gathering that information, step one. We're using that to measure quality, because quality is going to change over time. Our data changes, our users' interests change, right? There might be a strong seasonality, there might be an event, recency may be important. So quality and what's good constantly is changing. And so we want to be getting that measurement continually. And we want to use it to something we're calling the hybrid search optimizer. So we've talked a lot at this conference about the new neural search, right? Very, very exciting. But we also have classic keyword search. And right now, the process of figuring out how to meld those two together, there's some ideas, there's some rules of thumb, but they're all very rigid, and there's no constant feedback loop. And so what we're looking at next with leveraging our implicit judgments is deploying an optimizer in OpenSearch that can take your search quality and figure out globally, for our first pass, what is the right mix between your neural search and your user search, keyword search, and produce a base algorithm.
Possibly using other signals as well.
Yes. And how do we know it's working? Because we're using what our users are telling us by what they're clicking on using it. So, and we're going to deploy that. And then that process is constantly running and keeps on going. So that's something that we're driving towards the end of this year, is having that out in OpenSearch.
Yeah, so let me just comment on that. So
Please.
You've seen in some presentations here where people talk about where they use a lexical search for some queries and a semantic search for other queries. This approach basically says you probably want to use both on all queries, but maybe weight them differently and combine them differently. So short queries might have a heavier weight on lexical, let's say, and so on. So it's really trying to get to the next step of what hybrid is.
Yeah. And so we're starting with a sort of global approach, but very quickly we're driving into per type of query. If we can understand user intent, we can start understanding which of the various tools. We're starting with keyword and neural. You can imagine many different ways of blending these together to build the best search as measured by, thank you, User Behavior Insights, for giving us some great data for implicit judgments. So that's on our immediate roadmap. However, everybody's going to ask, wait, you're modifying the algorithm like every night and deploying that into production? That sounds risky. Yes, it is. And so I think some of the things that we're thinking about are better ways within our OpenSearch environment to responsibly deploy things. So interleaving. Interleaving is a way of very efficiently running an A/B test, especially for your long tail queries, where you can say, here is our current baseline algorithm, here is our challenger, let's interleave the search results by taking one result from each one, measuring who's contributing the best, and understanding whether our challenger is actually better than our baseline search by looking at our user behavior insights and data that we're collecting, all happening inside OpenSearch.
And one of our contributions here is that this is a well-known technique that was published a long time ago, but people struggle to implement it. So we want to make it something that's universally available by making it easy to deploy.
So if we get that in place, right, bandit algorithms, one of the things that we're going to be expecting is that our optimizers, whether it's the hybrid optimizer we're building in this project or what other people are going to be doing, are going to be surfacing, here's an array of potential great algorithms that are candidates for production. How do we efficiently test out that array of tests, right? We can't just do A/B tests. We need to be doing A, B, C, D, E, F, G, H, I, J type testing, right? And that takes up a lot of traffic. You're exposing to your users potentially algorithms that don't perform well and therefore hurting their experiences. So bandit algorithms is a way of being able to deploy many different algorithms and measure, hey, this algorithm, this candidate algorithm appears to be doing well. Let's drive more traffic to it. Here's an algorithm that appears to not be doing well. Let's reduce the amount of traffic that's going to it. And so it's a way of efficiently testing out lots of candidate algorithms on our users while still balancing their user experience needs and our other business metrics. So bandit algorithms. And then I think the last thing that I'm really excited about is really starting to think about what are, in these sort of fairly automated solutions, what are the guardrails that we need to have in place to make sure that our algorithms are still meeting our ethical values, aren't focused on one metric too much, and that we're giving our users great experiences. So thank you. Thank you very much.
Let me add one thing which we haven't said, and I'm a little embarrassed that we haven't said it, which is that Open Source Connections has deep experience in all of this area, and Eric in particular has deep experience and has contributed to open source with projects like Cupid, which we really should acknowledge as one of the inspirations for a lot of the work we're doing here. And one of the problems with Cupid that I think that we've observed is collecting the data. So collecting data was the bottleneck for a lot of this work, whether it's at our large customers that I mentioned, at smaller customers, at conferences, your consulting clients. It's a common theme that we see that the data just isn't good enough to support modern techniques of evaluating and improving search. So that's what we want to do with this very modest improvement, this very modest contribution really of defining a standard schema.